Bismillahirrahmanirrahim. Ladies and gentlemen, welcome to the online workshop on machine learning, and this is part 1. My name is Dr. Saleha Naghmi Habibullah. I'm a professor of statistics at College for Women in Lahore, in Pakistan. And also I'm honorary director of PISTAR. PISTAR stands for the Pak Institute of Statistical Training and Research, and this is closely affiliated with ISOS, and that is the Islamic Countries Society of Statistical Sciences. The focal person is Dr. Syed Wasim Abbas, Assistant Director at the Bureau of Statistics, Punjab, and the headquarters is in Lahore. And he is very much known to you because he has been sending to you all those emails. And if he had not sent to you the link today, then we could not have connected. So thank you so much, Dr. Wasim, for sending us the link. Now the PISTAR team is consisting of all these people. Our respected senior professor, Professor Muhammad Aslam, who has served for a very long time at FC College, Foreman Christian College, Lahore. Dr. Sharka Hashmi, who is assistant professor at the Lahore College for Women University. And then Ms. Saleha Mashkoor is our integral team member. She's lecturer at Minhaj University in Lahore. Ms. Kamal Aslam has graduated. She has completed her MPhil in statistics from College, Lahore, my own student. Ms. Aqsa Abid, she is also, well, actually, I think this is a slight mistake. She has completed her BSc, 4-year bachelor's program in statistics from College, Lahore, my own student. All right, the plan for today is, as you can see, after these words of welcome, I will be introducing Dr. Reza Arabi Belaghi, the lead instructor for this workshop, after which Dr. Sharka Hashmi will be introducing Dr. Alireza Safariyan, who is the co-instructor. I apologize right away if I'm mispronouncing your names, and when you are taking the mic, then you can correct me at that time. Then we will have this workshop on machine learning conducted by these two colleagues. And then we can have a short break, after which we can continue with the workshop. And you see there are 4 of them. This is only the very first one. Previously, Dr. Reza felt that maybe we can do it in 2 workshops. But I said to him that, you know, in Pakistan, the statistics community is not really much aware about, I mean, we keep hearing about machine learning, but we don't really know what it is. I requested him to go slowly but surely. I said it is better to spread it over four times rather than 2 times. Then after that, at about 4:15 or 4:17 p.m., this workshop, today's part will be ending. Immediately after which, inshallah, I will be introducing Dr. Donna Lalonde, who is a senior person at the American Statistical Association. Subsequent to which, she will be delivering her keynote address, and the topic is ASA, Promoting the Practice and Profession of Statistics. As you all know, ASA, the American Statistical Association, is one of the most prestigious statistical associations of the world. After that, we have about 10 minutes or maybe a little less for feedback from participants and some ideas maybe regarding what can be done in the future, etc. After which, Professor Muhammad Aslam, our senior colleague, will be presenting the vote of thanks, subsequent to which I will be doing the closing remarks. So this is the plan for the day. And now I'm delighted to share with you the names of the participants from within Pakistan: Ms. Baliga Yunus, Dr. Ambar Asghar, Dr. Kulsoom Akhtar Chaudhry, Mr. Muhammad Riaz, Dr. Hina Khan, Dr. Shakila Bashir, Dr. Itrat Batul Naqvi, Dr. Iram Salim, Ms. Safura Samuel, Ms. Shafqat Parveen, Mr. Mustansar Etazaz Amjad, Ms. Sabrina, Mr. Muhammad Sohail, Ms. Rahila Hafiz or Hafiz, and Ms. Aisha Sultan, Mr. Mirza Kalimullah, Mr. Muhammad Abdul Salam, Mr. Mustafa Nadimi, Ms. Uzma Maqsood, Mr. Muhammad Waqas, 5 persons from the State Bank of Pakistan. We are delighted to have you with us. We have Mr. Iftikhar Ahmed, we have Mr. Muhammad Zishan, Ms. Amber Zaki, Mr. Abdul Tawab, Dr. Razia Noreen, Ms. Aruba Siddiqui, Ms. Fiza Chaudhry, Mr. Isaac Shehzad, Ms. Saira Abid, and Dr. Naila Alam. We have international participants from so many different countries. As you just noted, we have Dr. Teresita Evelina Terran from Argentina, my dear friend for so many years, because we have been meeting at the IASE international conferences for the past many years. IASE, of course, stands for the International Association for Statistical Education. We have Dr. Waqas Sami, a very own person from Pakistan, but since now he is in Saudi Arabia for many years, so we consider him as an international participant. Dr. Najla Muhammad Karmala, she has been with us for all these workshops on Tidyverse, and I'm delighted to have you again for this one. Ms. Nadia Rahman from Canada and Mr. Yasser Rahman from Canada. I wonder if they have been able to join yet or not. I welcome them. Dr. Özlem Gönlü Alma from Turkey. We have Mr. Farhan Farouk from Denmark. And I think he's also very much from Pakistan, but at this time he's from Denmark. So let me regard him very much as an international participant also. Dr. Dean Langan from United Kingdom and Mr. Thomas Pavora from Kenya. If there are some more people, yeah, Dr. Mehnaz, I think from within Pakistan, from Lahore College for Women University, joined after I prepared these slides late night last night. So Dr. Mehnaz, your name was not there, but we will add it and welcome.
Thank you, Dr. Naghmi.
If there's anybody else, thank you. And if there's anybody else, please let me know right now so that it is recorded also that all these people are also here, other than all these names that I have taken.
Ma'am, my name is also not included in the slides.
Yes, my very own Shaista Shumaila from Connect College Statistics Department. See, if you people join so late, then this is what this is what happens. But you are more than welcome. I'm delighted. So
thank you,
please, my own team, Dr. Sharka Kamal, please note that we have to add these 2 names. Is there any other person? Please let me know right now.
Dr. Assalamu alaikum. I'm Sajid Rasool from Bureau Strategy, Punjab.
Oh, wonderful. Thank you so much, Mr. Sajid Rasool. He is the Director General of the Bureau of Statistics, Punjab. We are honored. We are really honored. He was our keynote speaker at the World Statistics Day 2020 PISTAR celebration of this day, which occurred just a few weeks ago. Thank you, Sajid Saab. Anybody else, could you please let me know? I think Dr. Amjad Javed Sandhu's name was not in the list. If there are other people, please do. If you don't want to say it right now, just text to me very quickly, because I really want this to be a part of these slides, which is of course our record. And also I would like to record it. Thank you each and every single one of you. All right. Without any further ado, let me introduce to you, ladies and gentlemen, Dr. Reza Arabi Belaghi. Before I go to the next slide, I want you to know that how we came in touch with him. You see, I think he was not aware of our Tidyverse first workshop, but then Dr. Shah Jahan Khan, the past president of ISOS, he assisted me in disseminating information regarding the second workshop. And that information, of course, Dr. Shah Jahan is in Australia, but all that what he disseminated, because of that, Dr. Reza came to know about our Tidyverse workshop, and I think it was the second one only, when he and his wife, who is also into statistics, Minu, both of them joined. And then later there was some, conversation between us, and I found out that he is, mashallah, he has a very strong CV, and I'm very impressed, a young person and such great credentials. So Dr. Reza, we are really looking forward to it. So let me, ladies and gentlemen, introduce him to you briefly. So he is at the Department of Mathematics and Statistics, doing postdoctoral fellowship, working with Dr. Abdul Qadir Hussain at the University of Windsor in Windsor, Ontario in Canada. And also he's working as Assistant Professor of Statistics at the University of Tabriz in Iran, because they are basically, both of them are from Iran, our very neighbor country, and our such a great friend. So educational background, postdoctoral fellowship in statistics, another postdoctoral fellowship in statistics from the McMaster University, Hamilton, Canada. He's visiting scholar, McMaster University, and he is a PhD in statistics from the Firdausi University of Mashhad in Iran. MSc statistics he did back in 2008 from the University of Tehran, and BA in statistics also from that same university in 2003. His employment history is as follows. This is a new term for me, seasonal faculty. I have heard so many different terms, but not this one. So it's very interesting for me. Seasonal faculty at the McMaster University in Canada. Also assistant professor, as I said already, at the University of Tabriz. All right, what are his research areas? Shrinkage estimation, machine learning, biostatistics, high dimensional data analysis. Please let us know, Reza, after a short while, whether high dimensional data analysis and big data analysis, are they the same thing or are they something different? 30 published papers and supervised not only 6 master's students, but also 3 PhD students. I particularly asked him to give me some, a little account of his experience with machine learning. So what is that experience? He developed clinical risk prediction models to predict preterm birth in Canada. So I think you can just read it. And I can now hopefully go to the next page. So using machine learning, Dr. Reza has successfully explored the main risk factors of preterm birth in Canada. Somebody please would need to mute their mic. And Dr. Wasim, you can please just see, because we are recording this. So ladies and gentlemen, if you would please mute your mic, that I'll be grateful. Please do write as much in the chat as you like. And my team, please take note of that. And if there's something urgent, then you can let me know. So using machine learning, ladies and gentlemen, Dr. Reza successfully explored the main risk factors of preterm birth in Canada. And now the practitioners can benefit from these models in order to provide treatments for their patients and to prevent this problem. Outcomes will advance the knowledge in the field, help decrease preterm births by developing possible interventions, and will save enormous amounts of direct and indirect costs in Canada. Dr. Reza has developed 3 papers as the main author and submitted to the British Journal of Obstetrics and Gynecology, the American Journal, and also there's another one, Obstetrics and Gynecology Journal, 3 prestigious journals. Ladies and gentlemen, now is the time for me to request my dear colleague, Dr. Sharka Hashmi, to present to you the resume of our second instructor, the co-instructor. This is Dr. Alireza Safariyan. So Dr. Sharka, is it all right if I keep on moving the slides?
Thank you, Dr. Saleha Naghmi. It's all right. A brief
All right, thank you.
introduction of Dr. Alireza Safariyan. Please come to the next slide.
Yes, I have done that. There's a slight screen delay, I think, between your
Okay.
computer
Dr.
and mine. Yes.
Okay, Dr. Alireza Safariyan, Department of Statistics, Assistant Professor of Statistics, Faculty of Mathematical Sciences, Alame Tabatabai University, Tehran, Iran. His educational background includes visiting scholar for the PhD Award, Statistics, University of Manitoba, Winnipeg, Canada, 2018. He did his PhD in Statistical Inference, Shahrud University of Technology, Shahrud, Iran, in 2019. He did his MSc in Statistics from Tabriz University in 2007 to 2009. He did his BA in Statistics from University of Tabriz in 2002 to 2006. Next, please.
Yes, I've done it.
His employment history includes Assistant Professor of Statistics, Department of Statistics, Faculty of Mathematical Sciences, Alame Tabatabai University, Tehran, Iran, in 2022 present. He was also an Assistant Professor of Statistics in Department of Statistics, Faculty of Mathematical Sciences, Shahrud University of Technology, Shahrud, Iran, in 2016 to 2019. Previously, he was Assistant Professor of Statistics, Department of Statistics, Faculty of Mathematical Sciences, Peyam Noor, Tabriz, Iran, in 2009 to 2015. His research area includes shrinkage estimation, machine learning, network data analysis, reliability, high dimensional data analysis, and he published 6 papers and advised 2 master students. His research papers are on experience with machine learning, estimation of centrality parameters of networks using innovative network sampling approaches on Facebook and Google Plus data. He was published 6 papers on the same topic, Facebook and Google Plus data. Next, please.
Okay.
For example, he was able to develop non-parametric model using spline method for estimating inclusion probabilities associated with forecast fire sampling from the network. This is very important problem and will help.
Forest fire.
Forest fire sampling from a network. This is very important problem and will help to develop more efficient design-based estimators of network parameters and opens the venue of further progress on the network parameters estimation using rank-based sampling designs.
All right,
Dr. Saleha.
Thank you very much. Thank you very much, Dr. Sharka. And ladies and gentlemen, it's now time for the workshop to begin. I just want to give you a recap of the plan. After we have introduced them, now the workshop is to begin, and then at about 3:30 we will have a break. But of course, it doesn't have to be exactly 3:30. It will depend on what they're saying at 3:30 p.m. Maybe it has to be 3:33 p.m. or something. And after that short, I should have written the word short very, very big because it's going to be very short. After this break, then the workshop resumes and it goes up to 4:17 approximately. It would not be able to go beyond that. If there's anything left out, we can try to do it next time. And then we have Dr. Donna Lalonde and the rest of it. So over to you, Dr. Reza and Dr. Alireza. I'm now stopping the share from my side, and I would like to request you to please share your screen.
Thank you so much, Dr. Saleha. Assalamu alaikum. And thank to PISTAR for developing this series of workshop. And I'm really delighted to collaborate with you. And it's really a big honor for me and for any people like in Iran to collaborate with very famous people in Pakistan. So this is really a great honor for me and my colleague, Dr. Safariyan, to join to this workshop and in fact present some of the in fact methods in machine learning algorithms, and we hopefully we can have a fruitful session today. So you asked something regarding to big data analysis and what's the difference between big data and high dimensional data. So let me start it with that question. So essentially, big data is now everywhere. Like we have tons of, billions of data coming day by day from Facebook, from Google. And so it's essentially really like in terms of terabyte or, even more than that volume of data. So we call this as a big data. So it could be an image, it could be a video, and it could be everything. And the art is to extract knowledge from this big data. But what is the high dimensionality in the sense of, in fact, statistics is that when we have, especially this comes from genetic expression analysis, and the issue is that, so we, in fact, I know that some of you may know the regression analysis, and in the regression analysis for each predictor variable, at least we should have 5 observations. So, but there are some certain cases in which we have many variables than the observations. So, if the number of predictors or variables are bigger than the number of observations, then we say this is a high dimensional data analysis. So, this is the difference between big data and high dimensional analysis. Now, I'm formally starting the session with machine learning algorithm. So let's start. So the outline of this session will be introduction to machine learning algorithm. Then we go through, so what's the machine learning and how we can do model selection and how we can do model evaluation. And we, in fact, we introduce in this session only 4 of these very simple algorithms of machine learning called logistic regression, penalized logistic regression, and its derivative like lasso, ridge, elastic net. And then we go through discrimination analysis. So through discrimination analysis, we will introduce what's the linear discrimination analysis, what is the quadratic discrimination analysis, and at the end, we go through a very non-parametric method called the k-nearest neighborhood. So here I want to take the advantage of the time to say some people believe that is it really machine learning or it's in fact statistical learning. There is a big debate between like a statistician nowadays and some people from computer science really to firstly to classify is that really machine learning or a statistical learning, because there are some famous people around the world called, for example, Robert Tibshiriani, a professor of statistics at the University of Stanford. He really believed that this is statistical learning and not machine learning. So, and what's the difference between these two is coming from, like when people talking about machine learning, they mostly emphasize on the computer side of the things. But when people talking about in fact, the statistical learning, then we think like these are some of the algorithms. So depending on if whether or not we, in fact, we introducing to a distribution for the data or not. So if we introduce a distribution like normal distribution, like binomial distribution, etc., then we go through like statistical learning, and that is nothing to do with machine. So all is statistical learning. So in fact, there is a big debate, even in big departments between big people around this area. But we don't, in fact, we don't want to go to that direction as it is a big issue. But based on very recent paper, like paper of Simon, let's see what's the learning. So learning is any process by which a system improves performance from experience. And in fact, machine learning is concerned with computer programs. So here is a very specific term. So computer programs that automatically improves their performance through experiences. So this is a very, in fact, important definition of what is, in fact, the machine learning. And when people, I mentioned, go through the machine learning, they mostly emphasize on computer programming rather than, just looking at the distribution, etc. And we will see what is the advantage of machine learning by providing some of the algorithms here. And in fact, that's really interesting to know that like logistic regression is a very, in fact, a statistical method. However, some people classify this as a machine learning. But we don't want to go to that struggles, to that problem. So we, in fact, categorize this, like these methods, even discrimination analysis, as machine learning methods, as they have, in fact, introduced in many of the books of machine learning. So let's see. So what learning is, and what is the difference between machine learning and statistical learning, and what is the learning process. So we see a picture in the left-hand side. So we have in the road different kind of apples, different kinds of peaches, and cows and dogs and horses. So without any hesitation, our brain learned, in fact, this experience that, and learn the type of, apples and what apples looks like, and what peaches looks like, what cow looks like, etc. And if in the right-hand side of the picture, if I give you like this type of figure, so then immediately you will see, okay, this is apple, and this one is a horse, and this is a cow, and this is a peach. Now the thing is how we learn, how we in fact categorize these fruits. So we learn from experience. So we looked at this in fact these figures here, and our brain in fact learn how to classify them. So whenever something, like in terms of characteristics looks like to apple, then we classify this one as apple, or other, like in fact animals, etc. So this is the learning experience, and all of the art of the machine learning process is that they can learn from the previous experience. But here is one thing that we need to know, is that machine learning essentially needs big data or more data than statistical things. So if the learning process is weak, then we cannot have a good prediction model. So, and there is in fact a difference between machine learning and statistical learning, which in fact is that, so in machine learning, we mostly emphasize on prediction. So this is a very important thing to know. So in machine learning, we mostly emphasize on prediction. However, in statistical learning, we mostly, sometimes we mostly emphasize on developing the reason. For example, we want to know why somebody gets sick. I mean, so based on some genetical characteristics, etc. However, in machine learning, we want to predict if he or she is going to be sick in future. So there is a difference between these two things, like statistical and machine learning things. And what I in fact, I'm going to double emphasize here is that machine learning algorithms and machine learning techniques need more data. And in fact, very recent paper published in this year, published in one of the best journals. The name of the paper is called International Evaluation of AI System for Breast Cancer Screening. So this is one of the, so this paper published in Nature, and you all know that Nature, in fact, is one of the best journal, in fact, the best journal in the world. And they shows that how AI system, specifically machine learning, a branch of AI, can defeat, can fail 6 other radiologists in reading the images of breast cancer. So, and this paper is quite interesting, and I introduce you, like whenever you have time, you may go through this paper and just have a look at this paper, how nicely, like machine learning defeated 6 radiologists like in a second, and then the 6 radiologists need to be, like trained for several years, and then, need to spend a lot of time to read the image and then predict you know, like whether or not the people are going to have a breast cancer or not. So these are some of the nice, interesting features of machine learning algorithms. So now, why we use machine learning, as I'm just going briefly why we need to do. So one thing is we can do things automatically, we can do things very fast. So this is like the basic of machines. So they are, though we train them, and this is one of the paradox about machine learning, is that though we train them, but they ultimately they become in fact more powerful than us. So one thing is that they are fast. Another thing is that they can mimic the human brains, which is very interesting. They can, you know, detect many, in fact, fraud, etc. So essentially how it works, and see, for machine learning, we have a training data. So we train the algorithms in the training data, and I will explain you in examples what is the training data. So our approach today is that, so we go through the techniques, and then at the end we'll provide you real examples from real world situation with our codes. So essentially we train the algorithms in the training data, and once we build the model, we can predict a new, in fact, query, and we can predict the new observations, what's going to be in the new observations. So they can, in fact, they can be used to image processing. They can be used to like different kind of disease detection. Nowadays, many people using them to cancer detection, etc. So the general thing is that we need an input as a training data. Then we need to train the algorithms, and those algorithms need to be very well trained to have, like, in fact, better accuracy. And we will see today how we can develop those things. So, and there are several applications of machine learning, as I mentioned. So for banking, telecommunication, for retail, for fraud detection, and many, and in biomedical things, for they are used to go to screening, diagnostic, and you know, drug discovery, etc. In computer, we can go through like spam filtering, text recognition, text translation, and so on, and many of them. And in fact, one of the nice things about maybe we can say that machine learning is better than statistics, is in the case that, in fact, in statistical things, we need some assumptions. So we will go through those assumptions. For example, in the linear regression analysis, so I think we have covered in the previous, you know, tidyverse section. So in linear regression, we need to have our data to have like normal distribution, or we need our data to be independent. Our predictor need to be independent. But one good thing about machine learning is that they are quite free of any assumptions. So which is very good. So they are free of assumptions. We don't need to have, you know, like independent features. We don't need to have, in fact, a normal distribution. And in fact, in the case of big data analysis, we might have, you know, like outliers. So when we have 1 terabyte of data for retail purchase or retail seller data, then we may have, you know, lots of outliers, lots of missing, lots of you know, that how we can, in fact, extract the data from billions of people, you know, from, for example, in the USA or in the North America. So Walmart is a very big company. Day by day, you know, millions of people are buying and purchasing things there. So now the thing is that if we go through statistical things, that will be, you know, really hard. And even harder than that is that if we want to go through like image analysis. So image analysis is something that, as a statistician, it will be very hard for us to go like to do image classification. And in fact, in one of our sessions, we will show you how we can do image classification and how we can do image analysis with machine learning. And one of the best algorithm of that will be deep learning. And in fact, we have planned to explain that. So now there are 4 basic steps to perform a machine learning task. So we need, everybody want to have machine learning, we need to follow these 4 steps for any model, for any machine learning model. So which is like the basic of machine learning. So first we need to have like a data. So in the first step, if you see my screen, in the first step, we need to have data. So we need to do some pre-processing for this data. And we will explain what this pre-processing means. We need to check for the missing data. If there is a missing, and then now the question will be how we can impute those missing observations. And which is in fact another effort we need to do that. So, and then we need to see if we need to normalize the data or not, or what. So there are some pre-processing, in fact, operations over the data, and we must carefully do them to have better models. So we need, in fact, some data cleaning. So as a statistician, a statistical work hard, data cleaning, like imputation or missing, or maybe deleting some of the wrong observations, etc. This step is quite important. Why? Because all of the result coming from the next session, like next steps, is strongly depending on the first step. So in the first step, we need to really to check for the outliers, we need to check for the missingness, and we need to check for the erroriness of the data. Some data are just flaws, and we need to be very careful for them. So now, once the data are ready in this form, in the form of the metrics, like data metrics here, so we will have x1, x2, etc. as like our features, and then we will have like an outcome variable here. So for example, let's say we have some features relating to the phone, and then the outcome is whether or not the phone has been
Hello, I cannot hear you
we
anymore.
can use them.
Okay. Did everybody hear him properly? The voice went for a short while.
We can't hear him.
Oh, do you hear now?
Yes, now, yeah, now I can hear.
Okay, sorry about that. So maybe it's because of my internet problem. So yeah, so we need to have like the clean data. So the first steps. So all these things that I'm explaining now, so will be the basis for the next, in fact, sessions as well. So first we need to clean the data. We need to see what is the outcome variable, what is the predictor variable, etc. So if we have outcome variable, we will go through a different type of machine learning algorithm. We will call that supervised machine learning algorithm. If we don't have the outcome variable, and if we want to see the like some patterns within our predictor variables or our X, then we go through like unsupervised machine learning algorithm. So once the first step is done properly, then we will look at which algorithms, in fact, we need to do in the second stage. So we will have sort of a different sort of algorithms, and all of those algorithms will have some things called hyperparameters. So what the hyperparameter is that, for example, we know the logistic regression, or we know the like linear regression model. So in linear regression model, we had some parameters called beta, or the coefficient of the model. So the coefficient of those model can be, in fact, calculated using maximum likelihood estimation if we had, in fact, the distributional assumption. But now in the machine learning algorithm, we don't have those distributional assumptions. That's why we need to, in fact, to use something called cross validation to optimize the model, or to find the best hyperparameters to, in fact, to produce our models. So here, like second stage is to using cross validation, and I will explain you what is what the cross validation means in the next slides. So once we did the second things, then we, in fact, we go through the third step as that we have a fitted model. We find the best model to fit the data. And once we have the model, so all of these steps in like step numbers 2 and 3, so we do them in something called training data. So, and I'll explain later what's the training data. So once we build our model, then we can like build an application, like a phone application, like Shiny application, to check stages for machine learning must be done. Is that so? One is called like training the model. So we need to train our model. So, and then we need to evaluate our model. Before any model come to, in fact, to application, we need to evaluate the model. So first step, we need to train our model. We need to build our model, but that's not enough. That's not, in fact, sufficient. The sufficient thing is that we need to evaluate our models. So, for example, there is a very recent paper published in British Medical Journal, and it shows that most of the machine learning models developed to predict COVID-19 were wrong. And it was very odd, like for even for, you know, for scientific things, they use machine learning algorithms without good evaluation. And then like after a while, in fact, the editorial board of British Medical Journal announced that you shouldn't use those machine learning algorithms. Why? Because the evaluation of the model has not been properly reported. So we need to be very careful if we want to, you know, to develop any machine learning algorithm. One is train well and then test well. So evaluate the model very well. And I'll show you in this session how we can do that. So from now, I'm going to be a little bit more quick because I think the time is passing. However, you know, this kind of thing is really neat to anybody want to, you know, to build any machine learning model. These are some cautions, and we must be very, very careful about that. So essentially, we have three kinds of machine learning. One is called classification, another is called clustering analysis, or supervised, unsupervised. So in supervised machine learning, we have the outcome variable, we have the predictors, or we have the labels, and we have the predictors. So for example, we have X, we have Y, and we want to fit a model to predict Y based on X. Now, in clustering, we don't have like the labels, we just want to see the pattern. So for example, we have many of genes, and now we want just to classify those genes based on being like benign or malignant. So this is the difference between clustering and classification, and we will go through like some examples along this sessions. So, and in a general setup, like machine learning can be goes through supervised, unsupervised, and reinforcement learning. So, and this session we mostly you know, emphasizing on supervised learning algorithms. So supervised machine learning algorithms, so we call them as predictive model. So what essentially the predictive model is that we want to give the features, we want to give the characteristics, or we want to give X, and we want to, in fact, to predict what is going on, what's going to be happen for Y. For example, if we have, you know, like medical characteristics of a people or a patient, we want to see whether or not he or she is going to develop certain cancer or certain cancer. Or another example, we want to use the genes to predict whether or not the guy is going to have a cancer or not. So here we want to predict something. So this is called as supervised machine learning algorithms. And how it works is that, so we have a data like called training text, document, image, etc. We extract those data with some nice features, and something will be called as variable selection. So essentially, not every information is important, but some of the information are quite important. So we need to in fact, to extract important features, because some of the features or some of the information will be just noise and just junk. And we don't need to use all of the junk information to build our model and in fact, to bring a very sophisticated model. So for example, if you have like 10,000 genes or 2,500 genes, it will be quite really hard to explain the outcome based on this amount of genes. So what we do is we essentially try to extract the most important genes, and then we use them to predict what is going to be on in terms of cancer. So in some case we have features, we have in fact predictors, and then we have labels. We train our algorithms, and once we train, we go through like prediction for the future. So I don't want to go to unsupervised machine learning too much today, as this is beyond our reinforcement learning is another things that we will cover for the next sessions. So and just for case of supervised, unsupervised. So if we want to have a very brief descriptions, in supervised machine learning we have inputs and outputs, and unsupervised machine learning we only have input variables. And so here is this picture show how they are. So like in supervised machine learning we have labels in terms of blue and red, while in unsupervised we just have some points, and we need to see if there are any cluster within this point, etc. So, and in supervised machine learning we want to have like this line to categorize the observations in either class, in blue or red. And now the challenge is which line is the best to do this, because once I get the line like through to the origin, I will get more misclassification accuracy in terms of red. And if I go through the to the right hand side, if I take this line to this here, then I will have more misclassification for the blue parts. So here is the challenge, is how we can fit this line, and the whole of the machine is the best line to categorize, or what is the best model to categorize people into, into blue and red. So this is the art of machine learning that we are going to say. So essentially, as I mentioned, in machine learning algorithms, we will have something called hyperparameters, and in real examples we will see what the hyperparameter is. So in order to find those hyperparameters, we need to use something called Kfl Cross Validations. So in Kfl Cross Validations, we divided our data in K-fold. So here, in fact, we need to do this in training data. So we developed the training data for K-fold. So we used like training for 80% of the data, and then we do prediction for the rest of 20% for each of the hyperparameter values, and then we will see by which the model have better performance, and then we select that one as, in fact, the model hyperparameters. And the reason that we do cross validation is that we cannot, in fact, find like analytical way to the hyperparameters of machine learning algorithms. So we need to use data-driven method, which in fact the best one is using Kfl Cross Validations. So for now, just don't worry about the examples, because I will really explain everything in the examples. And last things about like building machine learning model is that, so we start with training data. So then we in fact we evaluate the hyperparameters, we build the model. So we evaluate the hyperparameters based on Kfl Cross Validation. And once we build the best hyperparameters, we can use the model to prediction. So now once we model, or once we find the best models for our machine learning algorithms for any learning dimension, one of the most important stage, or even important than the first stage, is that to evaluate the model. So we had two things. One is model building. So for model building, we will use training data. For model evaluation, we will use testing data. So we will divide our data as training, testing. Mostly the best evaluation is something will be called as external evaluation. So so if we divided our data into 2/3, 1/3, or like 80%, 20% for training and testing, so it will be internal evaluation, which is not so bad. However, the best way to evaluate our models will be called as, in fact, the external evaluation. Yeah. So now, what are the measures for classification or supervised machine learning algorithm? There are certain measures to evaluate the models. So one is called for binary category. So if our outcome variable is binary, then like as a 0, 1, or yes, no, or sick, unsick, or like cancer, non-cancer, anything like that, then we need to check something called AUC, or called area under the receiving operator characteristics. So this is a measure. So the value of AUC will be between 0 and 1. So the more close to 1, it shows that the better model accuracy we have. So another thing is called classification accuracy. Once we classify the things, so we need to check if they are correctly classified or not. So mostly for so mostly for
please, somebody has to mute their mic. Dr. Wasim, could you please mute people's mic?
Yes, I have muted.
Okay, thank you. Yes, Dr. Reza, please go on.
Thank you. So yeah, for the binary category or for binary classification things, we need to use AUC. So if AUC is close to 1, then it means that our model will have a good discriminations. So another thing is classification accuracy. If we have multiple categories for outcome variable, in fact, we need to use classification accuracy. So we cannot develop AUC for more than 2 categories. So and also we need to have sensitivity, specificity, positive predicted value, and negative predicted value. And let me explain here what is those criteria. So let's say that this something we are going to predict disease and not disease. So there is actual things. So for example, like disease and not disease, and predicted values. So sensitivity is called true positive rate. So if we if we predict as a positive, we want to see how much of them in fact are positive. And so the true positive rate and false positive rate and true negative rate, there are some common things in fact, but very important in medical science. So we need to check for any model, we need to report it, we need to check how they are. And the better thing is that if we have all of those rates close to 1, that is the ideal things. But the thing is that it's like type 1 error and type 2 error in statistics. We cannot have both true positive rate and true negative rate close to 1. That's why the most important thing is the AUC. So once the AUC is closing to 1, it means that our model will have better discriminations. So for any model evaluation, we will see how we can, in fact, evaluate the model based on AUC, PPV, NPV, and so on. So these are some of the important things. Now, I am giving the time for my friend who, so for this, by this, we in fact conclude how we can build a machine learning model. What is the machine learning? So generally speaking, I'm just summarizing in 1 minute. So machine learning is something called a learning process from experience. Two main things that we need to be careful. One is machine learning need big data, relatively big. Now the question is how big is big? So 1,000, 10,000. So here the evaluation process will tell us how big is that. I mean, how big we need to that, because we need to evaluate at certain times. So step one is how we can build our machine learning models. So we said that we need to go through training models, and we need to find optimal hyperparameters. Once we did the first step based on Kfl Cross Validations, then we need to go evaluate our model. So if our model have good discrimination accuracy in terms of AUC, PPV, NPV, or other sort of things like negative, positive predicted values, negative predicted values, once everything is well developed, then we can say that I have developed a machine learning algorithms, and now somebody else can use for predictions or for for applications and so on. So these are some of the steps that in fact we need in machine learning algorithms. So in this session we will in fact explain 4 different types of machine learning algorithms called logistic regression, discrimination analysis, and care nearest neighborhood. So I'm giving the time to my friend so that he can explain them for you, and then after that we go through real examples with our codes. So thank you very much.
Okay, thank you, Dr. Reza. And maybe now Dr. Alireza will share his screen. Is that how it is going to be?
Yes.
Okay, Dr. Alireza, you can go ahead. In the meantime, I want to say to all the participants have been feeling that all these terms are very new for us. And you may be having a number of questions, just like I have a number of questions. So I would like to request you to please jot them down and email them to me, because even in that 5 minutes that we will have later, or 10, you wouldn't be able to have answers to all those questions. This will take these 2, 3, 4 months for us to properly understand. So I request your patience, as well as this request, very importantly, that you may please jot down the questions that keep coming into your mind, just as I'm having questions in my mind. Dr. Alireza, please go ahead.
Assalamu alaikum. Walaikum salam.
Walaikum salam.
Madam, I have a suggestion. If anybody has a question, then they put in the chat, and after that we will answer.
You have my voice?
Yes.
Yes, of course. That is, of course, the other option, that you don't write it anywhere else, but write it in the chat. Thank you. Yes, Dr. Alireza, please go ahead.
Okay, thank you very much. Thank you for your attention and present here. Thank you to Reza Arabi for his discussion about statistical learning and generality discussion about that. I want here to talk about logistic regression, a model statistical that can use to model a binary response variables based on predictive variables. Logistic regression is one of the most basic and widely used machine learning algorithms for solving a classification problems. The reason it's named logistic regression is that its primary technique is quite similar to linear regression. Logistic regression is a method used to predict a dependent variable called y, given an independent variable called x, such that the dependent variable is category. As you see in this picture, y is a categorical variable, and we can say that class of the 0 or 1, and anything that we can categorize it to, for example, yes or no, or voted or not voted, and anything, etc. When the response values are either 0 and 1, where you want to make expectation about response variable y conditionally x, you will have a probability of this y conditionally x. So if we use linear regression, this expectation will have infinity values from -infinity to +infinity. So to overcome this problem, we use another model to predicting this expectation using this yellow marked function that we called it is logistic regression. Another way to use this is Bayes rule, and we call it discriminant analysis. And we talk about that next section. For example, I brought an example about the disease of coronary heart. Some people in this training have or not have this disease. So we want to make a model about the relation of the age and having or not having these pieces. So in this table, you can see the age and people that have or not have this piece in the CHD column. If we make a scatter plot versus CHD, don't show very good relation if you compare it to regression models. Okay, you see that some of the people's are some of the people's response is 0 or 1, and we cannot find any visibility and things that we can explain about their relationship. Okay, how to remove some variation while still maintaining the structure of the relationship? Okay, answer is very simple. Create the intervals for the for age and compute the mean. Okay, then a clear picture of the relationship begins to emerge. You can see in this picture, if you make a category about the age, then our relationship will be describable, and we can explain model shape curve. You can see this relationship is very similar to a shape. So we want to find a function
We can't hear you.
that we can think about this as a linear equation in X or some transform. As I said to you, this mean in the table provides an estimate of expectation. Okay, we want to make expectation between 0 and 1. In X becomes progressively smaller as the conditional mean get closer to 0 or 1. Then a shape curve states that some well-known distribution function can be used to provide a model like logistic distribution function. If we call this expectation as pi x, then we use this model that will be surely between 0 and 1. Then this look at this logic transformation can explain a linear model. Logarithm of pi x over 1 minus pi x is ratio of as we call that odds ratio. The logit is linear in its parameters, may be continuous and may range from minus infinity to plus infinity depending on the range of x. Okay. In linear regression, y is equal to expectation of y conditional x plus epsilon. That epsilon has a distribution normal with 0 mean and constant variance. So the response variable y will be distribution of normal with expectation y conditionally x and sigma power 2. In logistic regression, with binary outcome variable, y will equal to pi x plus epsilon. So here we see that After this transition, y conventional x will be distribution of binomial with a probability pi x. When we talk about the pi as a probability of getting y equal to 1, we can see the curve of this equation will be S-shaped. Okay, the log of the odds ratio is linear in X. The LS method in the ordinary linear regression provides estimates with desirable statistical properties, but not in the case of logistic regression. Okay, this is where method cannot use this in this problem. So we use a general method of estimation that lead to the LS function under a linear regression model is the method of maximum likelihood. So if you want to estimate the coefficients, we use the maximum likelihood method. But here you can see we cannot find close form to estimating predictors equation. Okay, so we use the numerical method. In the Minitab software, we analyze this data of CHD, and we saw that some results about this. You can see log likelihood is equal to minus 53.67, and G is 29.3, and the others we will talk about this in the next slides. Okay, in linear regression, SST, a large value of SSR, suggests that the independent variable is important. Okay, while a small value suggests that independent value is not helpful in predicting this response. Okay, but in the logistic regression, comparison of observed and predicted values is based on likelihood function. We call that D, and we call it the D is deviance. Deviance is a statistical measure of goodness of fit of a model. A model with large the bad fit. So there are two types of deviance: null deviance and residual deviance. The null deviance presents how well the response variable is predicted by a model that includes only the intercept. Okay, but the residual deviance shows how well the response variable is predicted by a model that includes all the feature and coefficients of the model. The coefficients you know is they are beta coefficients and their statistical significance. Deviance in logistic regression plays the same role as the SSE plays in the linear regression. Okay, when we want to check that our model is good, we should minimize the deviance of the model. I don't want to talk about these equations. So in the finally, we try to analyze test of the equations. We use the chi-square distribution to testing this model. Consider a binary response variable y. Assume that the log of the odds ratio is this. When we have a lot of predictors, for example, x1, x2, up to xm. Okay, so we sometimes these predictors are have kind of collinearity, or they are too much more than our observations. So we will need to shrink them to a small bunch of the variable predictors. Okay. Our decision theory will be this: if our estimated pi is greater than 1 minus pi hat, we can assign our object to class 1, otherwise assign it to class 0. This is very simple, and we talk much more about this in our data analysis, real data analysis. This logistic regression can we can use it to ordinal response variable. Then we can have much more than binary response about the y. Another thing, make a response we can assign to our new object in the model. Okay, Dr. Reza will go on the penalized logistic regression. Thank you very much.
Okay, thank you very much, Dr. Alireza. At this point in time, I would like to recognize the presence of Professor Joachim Engel. Thank you very much, Joachim, for joining us. He is the president of the International Association for Statistical Education. He was one of our keynote speakers in the World Statistics Day program. Thank you again, Joachim. So, Dr. Reza, you can please proceed.
Thank you so much, Dr. Saleha, and thank you, Alireza. So, essentially, what am I going to try is that, so just I'm giving a brief description of what Alireza covered, is that essentially in logistic regression is as one of the machine learning methods. So what we try to do is that, so we try to do classification, right? So disease, not disease. So the item will be sold out or not being sold out, or you know, any classification, yes, no. So we have a bunch of or some kind of predictors called X. On the right hand side we have Y, and we want to predict Y based on this X, right? So one simple method is to use logistic regression. The logistic regression will assign a probability for Alireza will explain. So let me, so sorry. So if the probability of one class, we classify to either 1 or 0. So yeah, this is the nature of regression, logistic regression analysis. Simple approach. So we'll assign probability for 0 or 1. So whenever the probability of 1 is bigger than probability of 0, so then we classify like as 1, otherwise we classify as 0. So the whole, in fact, the major, the whole art of today's discussion is to classification to one of classes. So it could be binary class as 0, 1, or it could be like here a binary or multinomial class. So, and we will explain in the real examples. So what in fact is important and come like to through to machine learning is that, so in logistic regression analysis, if we have large amount of predictors, like a gene expression analysis or any other the large data, then we may have some difficulty regarding to something called multi-collinearity. So you know what is the correlation between two variables, right? So essentially, if two variables move in the same directions, like then we say that there is a high correlation between these two variables. And the more the correlation close to 1, it means that there is all of the coefficient of regression analysis, will be somehow like flawed because of the multicollinearity. So there are some certain of remedy for removing the in fact the predictors. I mean the correlated predictors, and one of the most important thing is lasso. We can go through like variable selection using a stepwise forward, backward, etc. But lasso is a new techniques and in fact introduced by Robert Tibshiriani. So it will force some of the predictors to go through 0, like to have coefficient of 0, and it will result to have.
Dr. Wasim, please mute the mic for somebody.
Thank you. Yeah. So if we use lasso, so the thing is models must be just noise. Then we need to remove the noise from our models. And one method to in fact to remove the noise is using some method called lasso models. So however, if we want to keep all of the predictors, even like if we want to predict some of the noise, a weak noise, then we could use reach. And in fact, Elastic Net is something between these two likelihood function. So if we have observations, then we can find the likelihood of those observations. So our models, in fact, are quite sensitive to parameters. So if we increase the number of parameters, then the likelihood will increase. However, it may not have it may not make sense because it may not add any good accuracy to our model in the testing data. So we need to penalize the likelihood function. So we give a penalty function. Different kind of penalty function. So one of the penalty function is like this. So summation of absolute value of beta j. So what is the beta j? So beta j beta j's are the coefficient of our regression models. So we want to penalize our likelihood function. So not to have as much as the coefficient the model wants. So there are different kind of penalty function. One is absolute, this is called as L1 norm. Another will be called as L2 norm. So in reach, and the last one is called elastic. So it's a combination of L1 and L2 norm. So these, in fact, these procedures they are all called penalized regression models, or so they are called penalized regression models. So they will, in fact, they will reduce the overfitting. So I'm introducing something called overfitting. What does it mean, overfitting? So whenever we have large number of parameters, then our model will have good training accuracy, but in fact, not in the testing, not good accuracy in the testing data. So in order to remove overfitting, we need to go through lasso or elastic net. So this is a remedy for using the overfit. So this is a schematic of what is the penalized, in fact, what's the penalty in reach. So you see the penalty in reach is a circle. However, in lasso, this is different things in lasso. So I don't go through too much on the theory of them. So there is a penalty, there is something called lambda, and we will see how it, in fact, how it contributes to our model. So as much as we, if we increase lambda, then if lambda goes to infinity, so this is called as, turning parameters. So if turning parameters goes to infinity, then we will have all of the coefficient might go to 0. So we will have a model with 0 coefficient, with 0 predictors. So we need to find this lambda. So please keep in mind, and I will introduce you in the real example, how we can introduce and find this best lambda so that we can have better model for, for reach or elastic net model. So the last thing we are going to discuss is discrimination analysis. So essentially, the discrimination analysis, as the main suggests, is that we want to discriminate between two category of observation. So we want, in fact, what we want to try is, we want to, in fact, to find probability of one class given the observations. So probability of G equal to K given X. So what does it mean? So you give me the observation X, and I want to find what is the probability of having a class number K for this observation. So we will have this probability for any of those K class. So if we have multiple class 1, class 2, until class K. So once, we need to find this probability for any class that this probability become maximized, then we categorize our observations in that class. So there is, in fact, pros and cons for different kind of machine learning algorithms. For logistic regression, in fact, one nice thing is that we can, in fact, introduce something called odds ratio, and we can use both of the categorical and continuous data for logistic regression. However, for discrimination analysis, we need to have continuous measurement for our X or for our predictor variables. So this is the schematic of discrimination analysis, and I don't want to go through these things. So if our classes have the same variation, then we may go through linear discrimination analysis. However, if the variance are not equal, then we may go through quadratic discrimination analysis, and we will explain for you. So here, there is a kind of discrimination analysis, and see how we can discriminate, the classes by these lines or by this curve. So we will see in the model how we can evaluate them by looking at the confusion matrix, or by looking at in fact, like AUC. So the ones that produce better AUC, then we will use that model. So it could be quadratic discrimination analysis, or it could be like linear discrimination analysis. So in general setup, we cannot we cannot decide it just by looking at the data whether quadratic discrimination is better or linear discrimination is better. We need to evaluate in the testing data. So the last thing that I want to Dr. Alireza to cover is that the K nearest neighborhood as the last algorithm. And after that, we go, if Dr. Saleha suggests, then we may go through break. And after break, we go through the real examples.
Dr. Reza, I think this is the right time for the break. Maybe we can have a break of 7 minutes now. And then after that, you can proceed, please. Hello?
Okay, okay,
yes.
Thank you so much.
And
okay,
the other thing is that I would like to request that maybe we can have the example coming now, because I have a feeling that if we have a real example coming first, then we will understand it better.
Okay, we can do that. Thank you. Yeah, we can start
Thank you
the
so
real
much.
example. No problem. Thank you.
Thank you very much. Okay, ladies and gentlemen, we have a break of 6 to 7 minutes right now. Thank you.
Okay.
Okay, ladies and gentlemen, I think we can resume. Dr. Reza, are you back?
Thank you, Dr. Saleh. Yes, I'm here.
Okay, I wanted to say, Reza, that all of us here are for learning, and I want to say that even if you are not able to cover all those topics today, please postpone them for the next time. But please do give us the examples in more detail so that we can actually see how this thing works on the real data. We've had a very nice lecture from you and from Alireza. I do think that the rest of the time today should be spent more on the actual real examples. If possible, I would like to request that.
Sure. Thank you so much, Dr. Saleha. And actually, I was expecting that the first part will be very hard. And because we have some, like very theoretical things. And I know,
मैसेज आई है नो वॉइस तू अपना
my
हेडफोन चेक कर माई
Please, Dr. Wasim, you have to mute people's mic other than mine and Dr. Raza's, because we are having these interruptions in between. Ladies and gentlemen, I would like to request you to please keep in mind that the mic needs to be muted all the time. I'll be very grateful to you.
Yep.
And please do use the chat to write down. Okay, Dr. Reza, please
Sure,
go ahead
thank
now.
you. Yes, so as we expected that the first part will be a little bit hard, hard, but I am going to explain with, very nice and simple examples, step by step, and then everybody hopefully will see how we can readily obtain, evaluate, and build the machine learning models based on that. So let me share the screen, and then I'll go through the data. So yeah, so the data that I'm going to explain is iris data, and I'll show you what's the data and how the data. But before that, we need to have some packages, and I'm just introducing those packages. So we need to have ggplot2. So, and then we need library Amila and library mice. These two are essential for imputation of the missing observation. So today we don't have anything to do with this too, but it is good to have this library and to introduce this library for the case of missing observation. So if we have any missing observation, we need to delete that row, or we need to impute that row by proper, data. Otherwise, our model will have, some problem and we cannot work. So there are certain library, and one of the most important of them is called Caret. So Caret is the main packages that we are going to use today, and after that we need to have E1071. So this is another package. So these three packages are quite important. So in next sessions we will introduce the R part package, the tree package, etc. But for now we must use Caret and E1071. So there is another things that in fact I'm going to introduce here before starting. So there is something will be called as imbalanced classes in machine learning algorithms. So where we have one class have quite a lot of observation. Let's say, for example, 99% of the people will go to class 1, only 1% of people will go to class 2. In this case, we will have something called imbalanced classes, and we need to treat the imbalanced classes as well. So a library called rows will be introduced for that problem. So another library is PROC. So I remember I mentioned you how we can use AUC to evaluate the model. So in order to have AUC curve, we need to use PROC. So PROC will be used for producing ROC curve. So there are also some other library as well, so like ellipse, etc. And I don't want to go spend more of the time. So I will clean this code once we finalize the session, and I will send the code for you, and then you can share the code with everybody. So here, so the data we are going to talk is the iris data. So let's attach the data. So, and then I'm changing the name of the data set, and here is the two rows of the data. See, like we have sepal lengths, sepal widths, petal lengths, petal widths, and we have the type of species. So the question is that, so we know the data. So these are called as variables. So how many variables do I have? I do have 5 variables. Variable 1, sepal lengths. Variable 2, sepal widths. Variable 3, petal lengths and petal widths. And this is called like the outcome variable. So the outcome is type of species. So it could be like setosa, versicolor, or virginica. So since I have only 2 of them, so I can show you the whole data. So let me show you the data set, and then you will see how it looks like. So see, this is the data that I do have here. So what we see, I have 150 observations, and I see like the delay, like so these are called as predictive variables. Why? Because based on this variable, we can predict what is the outcome variable or what is the type of the species. So we have, in fact, we will have 3 types of species here. One is called setosa. So the first 50 is setosa. The second 50 is versicolor, and the last 50 is virginica. So what the problem of interest is, in fact, is a classification. So I want to build a machine learning model based on this data, so that for the new observation, if I give the predictor variables like sepal length, sepal width, petal length, and petal width, I want the machine learning model or any of those machine learning model to predict me what will be the species, what will be the type of species. Now, I think the problem is clear for everybody what we are trying to do in supervised machine learning algorithm. Why it is supervised? Because I have the labels for observations, I have the outcome variable, and I do have predictor variables. So as I mentioned in the lasso regression or etc., or like in ridge regression or elastic net, if we have large amount of predictors here, then our model will become quite complicated. That's why, in fact, we need to go through like variable selection. But since I do have here only 4 variables, for this example, I won't go through variable selection. So now we are starting to give some description of data, to look at the distribution of data, etc. Since you know, I am starting with binary category, so let's see that we are only interested to see like a problem with binary class. So versicolor, if the data is like versicolor, if the outcome is versicolor, we will put yes. Otherwise, we will put no. So I did a little modification here. So, and I changed the outcome for the species. And now you can see like from here, we can see like how it looks like. So I'm going to write table for the outcome variable, and then you can see. So we have 100 no and 50 yes, right? So so this is our, yeah, so this is a supervised machine learning algorithm, so by which we want to start. Why it is supervised? Because I have the labels, I have the outcome variable, and the problem is I want to learn from this data, and then I want to predict based on these 4 predictor variables what will be the outcome variable, or what will be the class of the outcome variable. So in fact I did a modification, and I will tell you why I did in fact this modification, because it will be a really hard problem for us to detect in fact by just looking at the plots. So I changed the data set name kind of, and so now what we told is that if I want to build a prediction model, so firstly I looked at the data, right? So we can have a summary of the data set. In fact, so let me have a summary for this data set, and then you can see like or str of the data set. So we see our data will have like so sepal length is a numeric variable, sepal width is a numeric variable, petal length is a numeric variable, petal width also is a numeric variable, and our species is a factor, right? So again, that seems this is a like since we have outcome, this is supervised machine learning algorithm. So the levels are just no and yes. So this is just, you know, like
can I ask you right now, why do we have 1, 1, 1, 1 after that no and yes?
Oh, sorry. Could you ask again, Dr. Saleha?
The 1, 1, 1, 1 in after the no and the yes.
Oh, yes. So it assign no as 1 and yes maybe as 2. That's why. That's the reason for that. So
Okay,
however,
thank
we
you.
have like levels. So it will be, if it convert to the value, it will be 1 and 2. But the levels is no and yes, right? So
Okay.
now this is very important things. So we explained 3 of the machine learning algorithms. So in fact, we told that, so if we want to use logistic regression, that would be okay, because logistic regression could use any of like any type of predictor variables in terms of numerical or like factor. And we can use linear discrimination analysis as well, because they are continuous measurement. But if the predictor variables here, if they are not continuous, if they are factor, then we cannot use linear discrimination analysis. So this is the first things that we need to identify about how, whether or not we can use any types of machine learning algorithm. So yeah, that's important. The second things, now let's see, we have the data, and the data are quite clean because we don't have missing. So, and the data is like a standard data, we don't have outlier, etc. Maybe in next sessions I will introduced by how we can look at the to detect the outlier, etc. So, and here there are some plots. In fact, we can detect the outlier based on just box plot. So fortunately in this data we don't have missing and we don't have outlier. So the first things that we mentioned is that we need to train to find the model in training data. So we need to create partition. So we need to test, in fact, to use 70% of the data as a training, and then so we provide testing, and then we will have the data set, and for training and testing we have the dimension of data, and we have the class of data, we have the head of data, level of data, etc. So then we look at the distribution of the data set, and then what we see is we have 70 of no and 35 of yes. So we have, in fact, percentages here. So we built the training and testing in our data. And another thing that I am going to see is input to split the input and output variables. So X is our like predictor variables. So we have 4 predictor variables. So this is called as, if we want to go, so we have data set. So the first 4 rows, the first 4 columns are, in fact, are our predictors, and the last column is, in fact, our outcome variable. So as I mentioned, we need to check like how the distribution of predictor variables is, because if we have outliers, it might, it might affect our model. So I'm going here just to plot, in fact, a box plot showing the distribution of these variables. So what we see here is that, so we have like one, in fact, outlier here, and in fact, we might remove this observation, or we might keep, but fortunately we don't have a lot of outlier in this data. So we go through some of the plots to look at the distribution of our data. So we can have a feature plot to see how X and Y are moving forward together with the variables. So this is called feature plot. So let me enlarge this plot. So what we see is this plot shows how the predictor variables actually correlated to each other in terms of the 2 classes. So what we see is here, the red are yes and the no's are like, the red one is red, yes, and the blue ones are no. So we see that, so how petal lengths, and for example, petal lengths are correlated within these 2 classes. So, and we what also we see is that how the 2 classes have some, some overlap here and here and here. So, and then the art will be how we can classify and how we can identify these two classes based on machine learning algorithms. So let me go through
Dr. Reza, can you please tell us what do we have on the x-axis and what do we have on the y-axis?
Yes, so X and Y, they are just predictor variables. So for example, here we have petal widths, and here we have petal lengths. So this shows, this is the scatter plot of petal lengths. So this figure is petal widths and petal lengths. And we see how they, in fact, how they distributed along the X and Y axis. And this also shows like how the classes are, like how two classes are distributed and how they scatter in the XY axis. So just by looking
So
this,
so the blue one is the no, and the mauve color is the yes.
Right, yeah.
Okay.
Yeah. So we can have also plots. So based on those, so what we see also some of the nice plots that shows, for example, what we see is that, so for petal lengths, the average of petal lengths for no class is higher than the average of petal lengths for no class, right? So this is, so based on this, we can have like some sort of understanding. Like, for example, if the average is higher than this point, if the average is higher than this line, then we might go through to classify the items as petal lengths. I mean, as yes, or if the average is quite low, then based on petal lengths, we can classify as no, right? And here is also, but there is an overlap, right? So here's the average and it falls in this area. So there is an overlap and really it becomes hard. So here we see the average of, in fact, yes and no are quite similar to each other. So like this discriminating of the yes and no based on sepal lengths is becoming harder, right? So they have quite similar treatments. So so here there could be like a discrimination, because what we see is that based on sepal lengths, the average of sepal lengths for yes is lower than the average of sepal lengths for no classes. So, but now we see what's the classification and how it is hard if we don't use any of those models. So we cannot classify. So like if we do, like if we take like a rule and then we see, okay, any point belong, any petal lengths below this line will produce no, then it will be hard. So because there are some overlaps. So the ideal case would be if we had like this picture for here for nodes, and if we had something like the plot like this for here, like if there was no overlap, then our job was easy. But they are quite overlapping here, and in the next figure it will be shows even more how they overlap and how hard the task of in fact the discrimination. Now see, this is like another picture shows that how these two classes how overlapping. So what we see is that, for example, based on sepal lengths, we have quite overlapped here, right? So the distribution are in together, so really hard to distinguish, based on these characteristics, which one is going to be like pink or which one is going to be blue. So there is quite overlap. Now our models will learn from the experience, and we will see how accurately they can predict, this one or the blue one. So let's see how.
Dr. Reza, this is very, very interesting. Please do let me know, why is the blue one having the bimodal?
Yeah, this is in fact actually I don't know what the answer for this question, because the blue one, in fact, so for example, this is the distribution of petal widths for the no observation, and this is the distribution of petal widths for the yes observation. And you know, I don't have any good idea to say now, but what we see is the overlapping of these two classes, how you know they involved in together, and seems you know, discrimination is becoming harder for between these two classes, between blue and so what there are some, you know, some sort of thought come to our mind. So if you know, like the petal length is after this point or like less than this point, then we could categorize, you know, to the blue. Otherwise we could categorize, but there are some, you know, misclassification here may happen here. And then how about these two variables? So yeah, this is a really interesting classification problem for us. And let's see how our models, you know, can do this classification. So any questions so far, Dr. Saleha?
That's very interesting. Please continue.
Oh, yes, thank you. So now, these are some of the pictures that, in fact, we shows us how the what is the classification and how the classification could be a hard task if there is overlapping distribution between yes and no, or between two classes, right? Now, we mentioned that for machine learning algorithms, we need to first, you know, to in fact have training data. So we build the training data, and then we need to, in fact, to use something called tuning the hyperparameters or find the optimal hyperparameters, right? So this function is the most important function here. Shows that how we can, in fact, how we are going to train our models. So the function name called train control. So this function has several, in fact, arguments. The first argument shows is that how we are going to train our models to find out the optimal hyperparameters. So whenever I use method equal to CV, then it will show cross validations. And then the question is how many cross validation we need. So scientifically, anything between 5 to 10 is better, is in fact can work. So in scientific literature, it has been shown that 5 to 10 is good, but to me 10 is better. So like it shows that, you know, like 10 is better, but any of 5 to 10 you know, will work. And then we need to have a summary function. So here we will put 2 class summary. Why? Because we have, you know, 2 classes, and we also need to have class probability. So what class probability means? So we have 2 class of observations. One is the pink one, another is the blue one. So that's why we say like class probability. We want to classify the observations, and also we want to give the probability of an observation belonging to either of this class. So this is like very important things. And another important thing is to putting a matrix. So now we are going to optimize our model, right? So if we want to develop best models, we want to, in fact, to optimize the hyperparameters based on some metrics. And the metric in binary category will be ROC. ROC means receiver operating characteristic curve. So, and I will develop, you know, here how the ROC. So, but please remember that if we use accuracy in terms of metric, there will be a problem. Where the problem will come. So let's suppose we are going to detect the fraud in the bank. So we know that the frequency of the people who want to cheat the bank is quite low, maybe 1 out of 1,000, right? Now the thing is that if I put my metric as accuracy, then if my machine learning will tell everybody as correct person, nobody will cheat, then I will get the accuracy of maybe 99.99%, which is not correct because everybody classified as in one class, like maybe, you know, good people. So then that's why, in fact, we use in binary classification, especially, we need to use ROC. This is very important. Otherwise, it may become, you know, some wrong results. ROC is a better measure for discrimination of two classes. So now, once we, in fact, we said, like, this is called as, you know, like model building way, or like the way that we are going to build our model, how we want to build our model. So we want to build our model based on, you know, cross validation. How many cross validation? 10 cross validation. And we told our model that this is a binary classification. Why it is binary? Because we have yes, no, because we have blue or pink, because we have, you know, sick or not sick, because we have cancer, non-cancer. So this is a classification problem. We need to have ROC as our metric. Now, a very interesting package, very recently developed, the name is Caret, right? So I introduced the Caret package. So let me just here also write the Caret. So Caret will have a nice feature, and it can develop all of the machine learning algorithm based on this control function. So for example, let's see that we are going to fit the logistic regression analysis or a GLM. So in fact, the code is quite straightforward. What we need to do is we need to train our model, right? So first we need to build our model, or we need to train our model. So the function name is train, and then we need to put like what is the outcome variable. So the outcome variable was species in my example. So different kind of species. I can also, you know, show you what's the looks like. So for example, see. So here is I had 5 variable species was my outcome variable. And in any practical problem, in fact, we would know what is the outcome variable and what is the predictor variable. So, and we know the meaning of the predictor variables and the outcome variable. So the outcome variable is the variable that might be affected by some other predictor variables. So, and the predictor variables or the regressors or explanatory variables, they are something that might, you know, will affect the outcome variable, or they are the driver of the outcome variables. So we know the means of those. However, we might remember that we cannot include any predictor variable that we want. In fact, especially in the medical science, we need to be very careful. In medical science, we cannot include any predictor variables because there must be a biological plausibility for our data set, for our predictor variables. So how we can assess there is a biological plausibility? Any statistician, any machine learning developer must be in close contact with clinicians or with experts in that field that, you know, he are going to, in fact, or she's going to develop. So we might be in close contact with people to see what we should include in our model and what we should not include in our model. This is one of the most important things. For example, let me give you an example. So we wanted to predict preterm births in Canada some time ago. So somebody else, we looked, and then somebody else has put like birth weight as a predicted value of preterm. And we know that after baby came out, then we can measure the birth, right? So how it could be a predictor variable. Then they get a very accurate model, but no use of that, because once the baby came out, how we can, you know, use that weight to, in fact, to predict whether or not the baby will come premature or not. So that's why I mean,
right.
Yeah.
Right.
So
Dr. Reza, I'm interrupting you. You need to, you know, run this thing for us quickly because the time is running.
Yeah. So now we just, you know, need to put the outcome variable, and if we want to put all of the predictors, we need just to put tilde dot. And if we want to include 1 or 2 or 3 of them, we need to write their name. So it's very simple. So we need to specify our method. So the method name is GLM. The metric is metric. So the train control, we need to have the control function here. So now we run the code, and then, you know, like the model will come out. So this is the logistic regression, and we can have a summary of this model here. And mostly I am interested to go to prediction, and just let me run the other models as well. Then we will compare which model have better performance, and then we will see what is the benefit of machine learning for this. So the second one is called Glm Net. So GLM Net is something used to, in fact, to use like is going to use elastic net or lasso or ridge regression analysis. So essentially, it will show us that if whether or not the GLM is work better than GLM Net is working better than GLM or not. So here again the same thing. So we have train function, we have the outcome variable, we have the data set name, we have our method name. So if we want to use lasso regression or elastic net, then we need to put GLM Net method. And then what else we had is called linear discrimination analysis. So same code, just we need to put like what is the name, is called linear discrimination. And then we go through quadratic discrimination. So, and then we can have also KNN. So let me just quickly say what's the KNN here. So KNN is, let's say you are going to make a decision about somebody, whether or not he is a good man or bad man. So you will look at the neighborhood, right? So you will see who is his friend, who is, you know, this guy are chatting with, etc. So this is something called, you know, like KNN. So we will look at what mostly frequenting happen at that area, at that, you know, neighborhood. Then we classify, you know, based on that frequency. So now I am running all of my models here. See, like QDA, LDA, KNN. Now this is the nice things that will come out. So, and let's see the result. This is the dot plot. Now this is in fact the results to my machine learning models. So what we see is that, so KNN, in fact, in terms of ROC, KNN work better than other models, and also sensitivity and specificity. So KNN is a machine learning algorithm, right? And after that, the second machine learning algorithm is QDA, quadratic discrimination analysis, and elastic net, logistic regression, and LDA. What we see here is that now I found the answer for your question, Dr. Saleha, here is that since our predictor variable was somehow, you know, bimodal, that's why might be, you know, logistic regression as a linear model or linear discrimination analysis as another linear model may not work for our cases. And we really see that how, you know, like the three of machine learning models are better than like statistical model, logistic regression.
Dr. Reza, I'm not clear at all. Why did you say those are better and these are not? The ones which are on top, they are the better ones?
Yeah, so what we see is ROC, it means the ROC, right? So the more ROC, the better the model accuracy. The more sensitivity, the better model accuracy. And also the more specificity, the better model accuracy. So what we see is that KNN actually stand on the top and linear discrimination analysis stand at the lowest, stage. So
Dr. Reza, I'm still not clear. I'm not clear. I don't understand this. How do you, this vertical first box, could you interpret this? I mean, I don't know how to interpret this thing.
Yeah, so each model, so KNN, LDA, elastic net, so each model produced an ROC, so like a value of discrimination. So this is called area under the receiving operating characteristics. So this is in fact a measure of accuracy. So KNN produced the highest ROC, also produced the highest sensitivity. Why? Because it's here, it's close to 1. Also, so this is also close to 1. So KNN produced the maximum value of ROC, sensitivity, and specificity. That's why, and also this figure shows that, you know, like it is close to 1.
So what you're saying is that within each vertical box, or these 5 things, the more they are towards the right, they are closer to 1. And so they
are
right.
Yeah, the more close to 1, the better. So KNN, in fact, there is a confidence interval as well. But for the KNN, it's quite interesting that it is quite small. That's why it wasn't shown here. So yeah, the one that stands in the top is the best model that we developed based on this data. So here, and we see like KNN is a non-parametric method, is a really machine learning method, QDA another one, and so we see that it has better performance than other models. So we find out this one, and now let's go to the prediction. So to see what their performance in prediction and how they predict. For example, I go through like QDA, quadratic discrimination analysis. So for quadratic, we just need to, now we have built the models, right? So we have trained our models, we build our models, we found that how they work like within these plots, and now we are it is ready to use, and we are going to predict. We are going to see how is the classification accuracy, etc. So for example, let's put like QDA. So if I want to use QDA, so let me see. So so yeah, here is so here we have like spices, and here we have prediction. So prediction, let me see the predictions. So these are the predicted values, and the top one are the true values. So the first one is no, and our model in fact identified as no. The second one is no, our model identified as no, etc. So we in fact we see how they work. So we can have a table in fact to see how they looks like and how many of them correctly identified or not. So I can write a table right away. So the like table of predicted values and the table of the real values here. So yes, now the table shows that. So how the predicted values. So let me put here like predicted P equal to predicted, and then this one as actual as A as actual. So let's see how it works. So what we see is that so there 29 of the observation actually correctly predicted as no, 14 of the observation correctly classified as yes, and there are two misclassification here. And this is interesting because by looking at the distribution of the data, you know, when we look at that figure, it was somehow hard to see, you know, like how we can in fact classify this two observations. But we see here that the misclassification error will be 2 divided by the number of observations, which is quite low. And we can in fact do this one for any of the predictive models and to see how it turns out. Now we see the classification accuracies. I can also develop in fact the ROC curve, and then you will see like how the ROC curve is and how we can do the ROC curve analysis, etc. So let me go through this, and then yeah, this is the ROC curve. Let me enlarge the ROC curves. Yeah, this is the ROC curve, and it shows that this is for the in fact for the logistic regression. So this shows that our model has in fact 77.1%. So there are certain category for the AUC. So if the AUC is less than 60%, it means that there is no classification. There is no good classification accuracy. If the AUC is between 60 to 70, it means that our model can classify, but it has poor performance. If the AUC is bigger than 70, is between 70 to 80, it means that the classification accuracy is fair. And after 90 to like 90% to 100%, it will show the perfect classification. So based on this, we can conclude that our model has like a fair classification accuracy in testing data. And you know, this is the true life. And even like with the best models, in fact, predictors, still people are trying to predict cancer, and this is a long way. And you know, we need to even to have much more effort to increase the classification accuracy to get like 100% of the AUC, which in fact this is the ideal case. So Now, by this, actually, I have done.
Dr. Reza, sorry, I need to interject here.
Sure.
Our keynote speaker has joined. Dr. Donna Lalonde has joined from America. I would like to request you to please wind up the workshop for today in a few minutes so that we can have the keynote speech.
Sure, thank you very much. Yes, so I almost done. There is only one more example. So we covered in fact, the binary classification. The same things we can do for multiple category classification. The difference between these two is that in multiple category classification, we use the same, in fact, training, testing things. However, we mostly use our metric as accuracy. So we can run also like the same models with multinomial. However, for the GLM, we need to give like multinomial because it will not be like a binary. So I can run like the code is the same. Now, like everybody can use this code to produce any results, any machine learning based on this. Just we need to, in fact, to implement the data set. Just we need to change the name of the data set and so on. And just we need to go through training and testing and so most of the thing will be the same. So I don't have, I think I am going to, so the best is to give the time for the next speaker. So thank you very much. So if you have any question, I will be very happy to answer like within the session or after that. So thank you very much.
Dr. Reza, thank you for this. And we can always have this workshop, this example. You can do it again in the next one so that we can do it in detail. We can definitely have this example coming again next time. Thank you very much for this. If you allow me, I will now share my screen. Thank you.
Sure, go ahead. Thank you so much.
Okay, thank you. Dr. Wasim, can you see my screen?
Yes, madam, I can see.
Okay. Ladies and gentlemen, it is my privilege to thank Dr. Reza Arabi, Belaghi, and Dr. Alireza Safariyan for this highly, horizon-widening talk and all this demonstration. But as I said earlier, this is new for many of us. And, we need time to really understand things in detail. For that, I think we have to do a full semester course or 2 full semesters or 3 maybe. So, but anyway, the purpose is to, not only widen the horizon and to let people know all that what's happening in the world nowadays. And we in the developing countries also need to, be doing things to the extent that we can. The next item on our today's agenda is the keynote address by Dr. Donna Lalonde. And before I request her to share her slides and to go ahead with her keynote address, I would like to present to you a brief outline of her achievements. Dr. Donna Lalonde is the Director of Strategic Initiatives and Outreach at the American Statistical Association. And in this capacity, she tells us that she works with talented colleagues in order to advance the vision and the mission of ASA. Prior to joining ASA in 2015, she was a faculty member at Washburn University, where she was a champion for undergraduate research. Donna, I'm happy to share with you that at Kennett College, my institution also, we are very much focusing on undergraduate research along with graduate research. And in our institution, no student can get a BSc or BA degree without a piece of research. So I was delighted when I read this, and I'm now sharing it with everybody. At Washburn, Donna also served in various administrative positions, including interim chair of the education department and associate vice president also for academic affairs. At the ASA, she supports activities associated with presidential initiatives, accreditation, education, and professional development. The title of Donna's talk is ASA, Promoting the Practice and Profession of Statistics. So over to you, Donna. I'm going to stop sharing my screen. And I would like to request you to please open your camera also for a minute so everybody can see you, if that is convenient for you. Otherwise, you can go ahead with your slides.
Sure, I have turned my video on, so
Thank you very much. Now everybody can see you. And people, you have to pin the video if you want to see the big view. So you pin her and you get to see her with the, so she's one of our senior, very, very senior colleagues. And it's a great honor to have you with us, Donna. Please go ahead.
Thank you so very much for the opportunity. And I'm so delighted that I was able to hear a little bit of the machine learning talk previously. This is such a wonderful series that you all have created. And I'm a big R studio and R fan. Many of my colleagues work at our studio, so I know they provide a tremendous amount of resources. So delighted to see it being used during this series. Well, again, thank you so much for inviting me to give you this overview of the American Statistical. Maybe respond to some questions. Although I will say that, as you may know, when I'm in full screen mode, it is difficult for me to see the chat. So feel free to jump in with questions if I am missing a question. So one of the great things about working at the American Statistical Association is that we have, and I'm going to go out because my computer was being fussy about showing the slides. So we have strategic themes, and those strategic themes call on us to work in 3 areas: enhancing the diversity and breadth of our profession, increasing the visibility of our profession, and ensuring the future of our profession. And I'm going to do a little bit of a deeper dive into each of these areas and share with you some of the activities that are going on in the ASA. And again, ask for your input and ideas and thoughts on what we could and should be doing to better reach these strategic themes. The vision of the ASA is a statement that I love to share, because I think it does imagine a world that would recognize the talent and contributions that can be made by statisticians and data scientists. And it says, a world that relies on data and statistical thinking to drive discovery and inform decisions. A few weeks ago, in celebration of World Statistics Day, we collaborated on hosting a webinar on the future of federal statistics. And one of the takeaways of that webinar for me was just how much federal statistical agencies across the globe are contributing to this vision. So I like to think about the ASA vision as not only a vision for the association, but maybe a vision for the world as well. So what do? We spend a fair amount of time thinking about how to support our students and early career folks. So we have a Leadership Institute, and as a part of that Leadership Institute, we offer professional courses that help folks develop professional skills. So one example that I am particularly proud of is we have just recently started offering a expert witness training course. So as you may be aware, in the United States, experts in domains are often called upon to support lawyers in cases, and we have started this expert witness training course to hopefully encourage statisticians and data scientists to serve in that capacity. We also have a course on developing professional presence, which focuses on the communication skills one needs to be a leader. So those are just a couple of examples. We have mentoring programs which are done in association with the sections as well as in association with the conferences. And I have to say that attending the conferences and having the opportunity to match some of my early career colleagues with my more experienced colleagues is one of the greatest joys that I have in this position. And we do have a variety of other professional development activities, which I'll share with you a little bit later. And then finally, we do offer travel scholarships and awards so that especially students and early career folks are able to participate in the ASA activities. I did want to share a little bit about what we do in education. I will admit that most of our education efforts are focused at K-12 education in the United States, but I think with your help, that's something that we could make more global, and I would welcome your input and suggestions and ideas about how we might take the resources and make them more available. The motivation of the education program is of course to provide children with the opportunity to have experiences so that they recognize the rich world available to them should they pursue careers in statistics or data science. Some of the classroom resources that I'm particularly proud of is the Census at Schools, which is actually an international project, but that allows teachers in their classrooms to use data from across the nation, and as I said, actually internationally, to share with their students and have their students actually be able to engage in a statistical investigation, which is of course something that we want to encourage. We also have STU, which is statistics education on the web, and that's a collection of peer-reviewed lesson plans. We spend a lot of time with the support of talented volunteers developing guidelines and publications. And we also have an online journal called The Statistics Teacher. And then since Saleha shared that one of my passions is undergraduate research, I'm particularly proud of ASA Data Fest, which is held every spring. And that's a weekend event to challenge undergraduate students to engage with a very complicated data set and have the opportunity to work together in teams to draw insights from that data. We have had data fests internationally. We've had data fests in Germany and data fests in Canada. But again, I would offer up the opportunity to all of you who work with undergraduate students. It would be wonderful to expand the reach. For the middle and high school students, we have a feature with the New York Times Learning Network that's called What's Going On in This Graph, and that's a weekly feature through the school year. Pretty, very, very fun feature. It takes a graph from a visualization from the New York Times and challenges students to think about the data and the statistical investigation underlying that graph. I'm delighted to be able to give a shout out to, in our Engage category, to a podcast, Stats and Stories. John Baylor and his colleagues at Miami University explore really interesting topics that are of current interest. I'm sure John is familiar to some of you because he's currently serving as the president of ISI. And so we're delighted to be able to partner with Stats and Stories. We have an outreach campaign on the web called This is Statistics. We have a science and policy and advocacy where we try to advocate for good practice. This has been especially important for those of us in the United States around the issues of the census and obviously globally for the COVID-19 pandemic. And in that light, we do try to provide resources for policymakers. So who are we? Well, 50% of the ASA members work in academia, approximately 10% work in government, and approximately 40% work in business and industry. And we do have about 5,000 student members, and those student members do range from graduate students actually to high school students. So we love to have high school students join us and think early about careers in statistics and data science. So this is a long list, and it's not necessarily the best way to display this this just long list on a slide, but I actually wanted to show you this because this is the list of all of the sections that we have in the ASA, and I wanted to call this out to you because the breadth of topic areas that are represented by the sections is one way to show the breadth of interests that are represented in the ASA community. And so you will see that we have a variety of sections, that some of the sections have been in existence for a really long time. Biometrics, for example, was formed in 1938, to sections that were formed, Statistics in Defense and National Security in 2004. And so sections can be created as new topics emerge. The Life Data Science section was established in 2019. But oftentimes when I talk to especially the early career folks, I realize that sometimes we don't give a sufficient shout out to the expertise that is collected in the sections, which is all around an interest in a particular area. So if you are an ASA member and not a member of a section, I would encourage you to join. And obviously, if you are not an ASA member, I would invite you to join the ASA and take advantage of the sections, that the talent in the sections. And especially, I guess, related to the previous presentation, we have a Statistical Learning and Data Science section, which is incredibly active and also spends a lot of time thinking about webinars and workshops that can add to the knowledge base of the members. And so I think especially those of you interested in the machine learning and AI would find that section useful. And then, of course, I'll give a shout out to statistical computing and statistical graphics for those of you interested in learning more about using R and RStudio and data visualization. And finally, I would say we have a very active section on statistics and data science education. And if you didn't find your interest represented in the list of sections, there's an opportunity to form an interest group. And so to just complete the list of domain available options, I show you here the interest groups. And so I'll give another shout out for encouraging folks to join the ASA. We do have a variety of membership levels available, including a student membership, a developing country membership, and an early career membership. As I'm sure many of you know, we host a number of conferences. I'm particularly proud of the Women in Statistics and Data Science Conference because that's one that I work with. I'm guessing that many of you know about the joint statistical meetings and probably have participated in JSM. We also have a conference on statistical practice, which this year will happen in February and will be virtual. an international conference on establishment statistics, the conference on health statistics and policies, and a relatively new conference, the SDSS Symposium on Data Science and Statistics. I would be remiss not to highlight for you the number of journals that are available, and also to give a special, to ask you to pay special attention, I guess, to the articles, the magazines that we publish, which include Chance, Amstat News. Significance is of course the publication of the Royal Statistical Society, but is available to members of the ASA. And Chance, Amstat News, and Significance have just a wealth of great articles from stories that tell you about members of our community, that highlight special programs. And so I definitely look forward to an article in Amstat News about this wonderful conference series that has been arranged. Well, of course, I got to meet Saleha because she was an educational ambassador. And so I wanted to mention the Educational Ambassador Program. It's one of the highlights of JSM for me. And I hope that in the future we are able to be in person at JSM. The Educational Ambassador Program selects two individuals to participate in JSM. The cost of attendance is covered by the American Statistical Association. That includes travel and a small stipend. The educational ambassador is then asked to participate in a continuing education course or courses, and then to go back to their home country and to share the knowledge that they've gained. And so that's a very exciting opportunity. And again, I hope we are able to meet in person again, but call that to your attention. Also, we do have an accreditation program, both PSTAT and GSTAT. GSTAT is the Graduate Statistical Accreditation Program. So if you have students who have obtained a master's degree, that GSTAT is open to folks who have an advanced degree in statistics, data science a related area. PSTAT is the professional accreditation. It is portfolio based, but it is a way to acknowledge to the world's community your expertise and education and commitment to ongoing professional development. With my colleague Ron Wasserstein, I work on the accreditation program, so would welcome any questions about accreditation either now or if you feel free to reach out to me in the future. So I mentioned professional development, and since you all are you were using talking about machine learning, then I wanted to share with you some of the opportunities around professional development on the technical area that are coming up in the fall, and these will be virtual given our current situation. But what might be of interest for some of you who are new, we have an introduction to R for non-programmers, and then all the way to weighting methods and surveys. And so we do try to cover in our technical professional development areas in a variety of domains. And we're always actually interested in input. So please feel free to share if there are areas of professional development that you would like us to be focusing on. The professional development does include face-to-face courses when we are meeting face-to-face at conferences, but as I indicated, many of them are offered web-based as well. So we want to be known as the big tent for statistics and data science. So I will say that I think that the benefits of membership in the ASA are the connections to the broader statistical community, access to the journals and to the magazines. We do try to support career. If you are a member of the ASA, I'm sure that you've seen on ASA Connect, our online community, and in a variety of our online communities, we share about jobs that are available, but we do also have a job web, and we have a career service at JSM and at some of the other conferences as well. So we're obviously wanting to support both employers who are looking for talented statisticians and data scientists, but also our members who are looking to make a career change or to begin their career. And then, as I just previously mentioned, we have we spend a lot of time thinking about it and hopefully delivering professional development activities. So I will conclude with saying I'd be happy to talk about questions, but I'm also sensitive to time. That's my email address, and I would love to correspond with you, and so please do feel free to reach out. And thank you for very much for this opportunity to meet all of you and to learn a little bit about machine learning and participate. I appreciate it greatly.
Thank you very much. That was great. Thank you so much, Donna, for giving us so much in such a short time. And you've explained so much. I mean, you've covered everything, I think, and it's a lot of so much different dimensions, so many dimensions. I think my colleagues here in Pakistan and also other colleagues, we have people from Argentina, from Kenya, we have people from Canada, we have people from Saudi Arabia. Of course, we have the two gentlemen who are our resource persons for today's workshop from Iran, and we have so many other people. So we are all, I think, on behalf of everybody, I think I should say that it has been just great. As far as the questions are concerned, I need to apologize that I would not be able to allow everybody to speak because of the shortage of time, but I would like to say that if Professor Joachim Engel, who is the president of the International Association for Statistical Education, IASE, if he could maybe make a comment. Joachim, would you like to do that?
Of which I am a proud member as well.
Yes, of course. Joachim, can you hear me? Maybe he's not near the phone, near his computer right now, I don't know. And Mr. Sajid Rasool is the Director General of the Punjab Bureau of Statistics. We are honored to have him too. Mr. Sajid Rasool, if you are here, could you please make a comment now? I think he has got disconnected. Okay, I would open it to all of you. Anybody who would like to, who has some burning question or some comment, it's now open to everybody because I couldn't, I think they're not here right now maybe. So Dr. Kulsoom, would you like to say something right away? Dr.
Assalamu alaikum and a very good evening to all of you. This is Dr. Kulsoom Akhtar. I'm heading the statistics department at Kfl College for Women, Lahore. First of all, I would like to thank you, Dr. Donna, for the detailed talk. I mean, as Dr. Saleh Naghmi has reported, that you have covered almost all the aspects and the characteristics, fundamental characteristics of your esteemed organization. So it was wonderful to hear from you. And I would love to share with you that here at Kfl College, we are planning to hold an event on 29th of November. And it is in recognition of the International Year for Women in Statistics and Data Science. And for that, I've requested Dr. Saleh Naghmi, who is a senior member of our department, that she should contact the esteemed speakers like you who could, who would be able to join us on that event, and they can, share their talk on that. So it would be a great opportunity for us to hear from you further, so that our students and alumni who will be joining us on that event, they would love to hear from you for that particular event. So thank you so much.
Yes, thank you so much for mentioning. I should have mentioned the International Year of Women in Statistics and Data Science. So that sounds like a wonderful event, and I know I and my colleagues would love to listen in.
Okay, thank you very much. I do want to say that I want to share with everybody, and particularly with Dr. Kulsum, that I have written to John Baylor, the president of the ISI, and I hope that he will be able to join also. And Donna, if you're just like today, if on that day also you could wake up early, like it is, I think, very early morning for you as well, then that would be great. Also, we have Teresita from Argentina, and she's also one of our invited speakers in one of the upcoming events of PISTAR. But for her also, it's very early morning. So it's very kind of all of you to, honestly, it's very, very kind of you to do this for us, even if it is not the optimal time in the day for you. And you're still being with us. It is great. Thank you very much for this. I will now share my, thank you. I will share my screen now. And I will go to the...
I just wanted to say, I put my email address in chat. So again, please feel free to reach out. It would be great to connect with some folks. Yeah.
Thank you. Thank you very much. I'm sure people will be doing that. You see, there's so much that you have shared with us. You have talked about I jotted down a few things only that I could continue to talk to you about with, like this data fest, the data fest. I think this would be great if we could collaborate with you on this. And then, of course, the GSTAT, the accreditation for the students, and then the PISTAR, the professional accreditation. And of course, I was fortunate to be there for the JSM. It was amazing, 7,000 people and all that. It's just, ladies and gentlemen, I would like you to, to take the opportunity to connect with Donna and to talk about what you can do, what we can do further for the development of statistics and statisticians. So I would now like to share my screen, and I would like to get to my remaining slides. And of course, a sincere appreciation and thanks to Donna. And after that, what do we have next? Next we have, because it's almost time to end today's program, a vote of thanks by Professor Muhammad Aslam. He is the Senior Vice President of the ISOS Executive Board and also the focal person for the PISTAR Statistical Consultancy Service. Donna, I would like to share with you that PISTAR, of course, is the Park Institute for Statistical Training and Research, and it is intimately connected with ISOS, the Islamic Countries Society of Statistical Sciences. So without any further ado, I would like to now request Professor Aslam to present the vote of thanks. Would you want me to do the slides, which I am already sharing, Professor?
Yeah, you will do, Dr. Saleha. Bismillahirrahmanirrahim. Professor Dr. Saleha Naghmi Habibullah, convener of this online workshop on machine learning. Dr. Reza Arabi Belaghi, the lead resource person. Alireza Safariyan, co-source person. Dr. Donna Lalonde, the keynote speaker. Valuable participants of the workshop, ladies and gentlemen. It is my pleasant privilege to present vote of thanks on behalf of Park Institute of Training and Research at the end of this online workshop on machine learning. There is no denying that the need for handling large masses of data is increasing day by day. The emergence of recent techniques and new technologies need optimize propagation and training. I take this opportunity to pay tributes to late Professor Dr. Munir Ahmed, a great visionary who founded this Park Institute of Statistical Training and Research as a platform for sharing knowledge and expertise. The keynote speech and the discourses of both the resource person and the co-resource person were thought-provoking and highly fruitful, for which all three valuable personalities are highly deserve. Three persons to this workshop deserve sincere appreciation and gratitude from both from PISTAR and from the participants. We are thankful to the participants of the workshop. We are sure they must have learned a lot. PISTAR appreciates with thanks the efforts of Professor Dr. Saleha Naghmi Habibullah and her team, especially Dr. Wasim Abbas, for organizing this international online workshop. Our special thanks to Mr. Muhammad Iftikhar and his staff for helping us and helping for all the help and support. Thank you all once again, ladies and gentlemen. God bless you.
Thank you very much, Professor Aslam. Thank you for the vote of thanks. I think it is just about time to, to complete this workshop. But let me share the screen one more time for the closing remarks. I just wanted everybody to know that today we were privileged to have with us all these ladies and gentlemen from within Pakistan. There's so many more. This time we have 3 slides full of names of our dear colleagues from various institutions and universities and other kinds of institutions of Pakistan, State Bank of Pakistan, the Bureau of Statistics Punjab, the Pakistan Bureau of Statistics, so many universities, other organizations. So I would like to thank each and every one of you, my dear colleagues from within Pakistan. We had with us today Dr. Teresita Tehran, Dr. Waqas Sami, Dr. Najla Karmala, Ms. Nadia Rahman, Yasir Rahman, and Dr. Aslam. Dr. Aslam from Turkey. I think he joined a little bit late, but later then I saw that he was very much there. Thank you very much, Dr. Aslam, for being with us today. Mr. Farhan Farouk, joining us from Denmark. Dr. Dean Langan from UK. I'm not absolutely sure whether he was actually able to join. And of course, Thomas, our regular participant from Kenya. Thank you very much, every single one of you. The PISTAR team, as Professor Muhammad Aslam has already said, I also want to acknowledge their contribution. I cannot proceed without their support and tremendous support. I would like to take the names of every person: Dr. Syed Wasim Abbas, Professor Aslam himself, Dr. Sharka Hashmi, Ms. Zulekha Mashkoor, Ms. Kamal Aslam, and Ms. Aqsa Abid, the new entrant in my team and as dedicated and committed as anybody else. Ladies and gentlemen, this is the time to say goodbye, and hopefully we will meet you again on the 13th of December. So many of you had already registered for the entire, the bundle of 4, the 4 workshops that are to happen. And the ones who did not, I would like to recommend that you do that, because obviously we want to learn something and we cannot learn it in one day. So it would be nice, I think it would be good if you would join us on the 13th of December, and then in January, and then on the 7th of February. So we have a series of 4 workshops on machine learning. Okay, ladies and gentlemen, this is the time for me to say thank you and Allah Hafiz.